Now we're asked to take the second derivative of y equals x cubed. Again, that's very easily done. We get derivative 3x squared, and then the derivative of that is 6x. So that's the second derivative. We could plot the second derivative, straight line graph, through the origin, negative when x is negative, positive when x is positive. That's related to the graph of y prime, the first derivative. First derivative, of course, is 3x squared, and of course this function then is a derivative of this one. And we notice that y prime being 3x squared has a graph that looks like this, vertex at the origin, and y prime is decreasing for negative x, to the left of the y-axis. As x increases, y prime decreases, meaning that the graph of y prime would have a negative slope. Well, the slope of the graph of y prime at a point is equal to the derivative of y prime at that point. So that at every point to the left of the y-axis, the slope, being negative, would give you a derivative that's negative. Well, here's the derivative of y prime, and to the left of y equals 0, the derivative is in fact negative. The derivative is 6x, and that's 0 to the left of the y-axis. To the right of the y-axis, the derivative is positive and also increasing. Derivative is positive here and increasing. Are the slopes, let's say, are positive and increasing, so the derivative of this y prime function should be positive and increasing. And that's the case here. The derivative, or the values of the y double prime graph, which represent the slopes of the y prime graph, are positive and increasing. So, again, let me write just a little more in here to make it doubly clear. Okay, to make this really clear, hopefully, to the left of the y-axis, the values of y double prime are negative and increasing. To the right of the y-axis, the values of y double prime are positive and increasing. On the y prime versus x graph, to the left of the y-axis, the slopes are negative and increasing. To the right, the slopes are positive and increasing. What happens? Well, the statements we can make about the slopes of the y prime graph are the same as the statements we can make about the values of the y double prime graph. And the reason, again, is very simple, because the slopes of this graph are the values of the derivative of y prime. Derivative of y prime being y double prime. So anything we say about the slopes of the y prime graph, we're saying about the values of the y double prime graph, because of the identification with the slopes of this graph with its derivatives. And another set of statements we can make is that y double prime is negative where y prime is decreasing. Y prime is decreasing to the left of the axis, y double prime negative to the left of the axis. Y double prime is positive and y prime is increasing. Y double prime is positive to the right of the y-axis. Y prime is increasing to the right of the y-axis. Important sets of relationships that it's really good to understand.